Hey guys, welcome to your Chapter 9, Lesson 3 notes on solving quadratic equations. By the end of the day, you'll be able to solve quadratic equations with two methods. The first is by graphing. You'll look at a graph of the parabola and you'll see, okay, nice, where are my solutions at? And then the second way is by using square roots. So you'll have like some sort of x squared equals, some number, whatever that is. And you'll take square roots to figure out what that is. So anyway, a quick review. Remember that quadratic means squared. So a quadratic equation is one that looks like this. You have some number times x squared plus another number times x plus some other number equals 0. You're trying to figure out what does x equal to make this whole expression equal to 0. There you have it. That's your key idea. What is x to make it equal to 0? Now, since we have our exponents in decreasing order to 1 and then no, we call this the standard form of the equation. So it's pretty standard. Cool. Now, the solutions of a quadratic equation are where y equals 0, where this equals 0, where the graph intersects the x-axis. Because that's kind of like where it stems from, like that's where it intersects the ground. We call them the roots of the equation. We also call them the zeros of the function. There shouldn't be little periods right there. So, my bad, I did not catch that. There you go. Okay, so yeah, to find the solution, that's where, if you graph it, where y equals 0, or the roots of the function. So go ahead and spend some time graphing these guys down here. Pause the video and graph them. I did already. Oops, that's not any sure. That is though. So here's the first one. Now remember, the solution is what happens when you take this graph, x squared minus 16. X squared minus 16. Yeah. So you graph the equation y equals x squared minus 16, and you want to figure out when is that equal to 0. That's always going to be equal to 0 on the x-axis because you don't go up or down at all. And those points are right here and right here. So we would say that x equals -4 or x equals 4. You can write your answer like that. That's kind of lengthy. So normally, normally you'll see your answer like x equals -4, 4. So that's fun. They won't always be opposites. Like it could be -8 and 2, or -6 and -5. These just happen to be -4 and 4. So, yeah. So this guy, where are his zeros? Well, where does he intersect the x-axis? Oh, he doesn't. So we say that this guy actually has no solution. That's because there is no x that will make this true. Because, well, we'll get there later. There's no solution. If you really want to know why, ask me in class. Aha. Okay, here, look at this guy. I graphed him, graphed all those points, connected them, made a beautiful parabola, and it only intersects the x-axis here at x equals 0. So that is its only intersection, x equals 0. Because there was only one point, there's only one x value that makes this equation true, we say that this guy has one solution. This guy has no points that makes, no x's will make this equation true. We say he has no solution. Oh, 0. 0 solutions. And this guy, well, you can see, has 2 values of x that will make this equation true. So we say that he has 2 solutions. There you have it. Okay, so graphing is really nice when you can look at the graph, but it takes a long time. It takes a long time to make a graph of a function. So if you have a graphing calculator, that's super fast. But otherwise, there's a faster way. Before I tell you that faster way, let's review some concepts. Okay, sweet. There should be like a, what is that right there? Okay. Example A says, what is the square root of 36? Well, I know the square root of 36 is 6. Why? Because 6 times 6 is 36. Great! But guess what? Negative 6 times a negative 6 gives us a negative times negative is positive 36. A challenger appeared, right? So yeah, you have positive 6, but you also have negative 6. So square root actually has 2 solutions. Yes, positive 6, but also negative 6. So you need to write your answer like this, plus or minus 6, which means 6 and negative 6, like that. So it's just like here. You're trying to figure out, oh, hey, look, what are the square roots of 16? The square roots of 16 are 4, yes, but also negative 4. That's why it has 2 solutions. Here, what are the square roots of 81? Well, yeah, it's 9, but guess what? It's positive 9, but also negative 9, because 9 times 9 is 81. But fun fact, negative 9 times negative 9, also positive 81. Ha ha ha! This is my favorite one. 0 is not considered positive nor negative, so you just straight up have one solution here. Square root of 0 is just 0. So that's cool. But then, what's the square root of negative 9? People are quick to jump to negative 3. But guess what? Negative 3 times negative 3? Positive 9, which is not negative 9. So that can't be it. Turns out this guy has no solution. Haha, that'd be great. Okay, so this is like a stay tuned for Algebra 2. Coming next season, the cliffhanger of algebra right there. Sweetums. Okay, what are the solutions of the equation? Hey, you know what, guys? Whenever we find solutions, you're just trying to figure out what is x. So let's do what we can. Well, I look at this and I immediately see, okay, I want to get x all by itself. So I'm going to undo everything that's happening to the x. Those 16s will cancel out, super duper. So I get x squared equals 16. Cool. Now I still want to get x all by itself. So how can I undo this squared right here? Well, I'll take the square root. So you need to take the square root of both sides. Square root and x squared, those will cancel out, leaving you with just x. And then we need to figure out what is the square root of 16. Well, I know the square root of 16 is 4, but guess what? Remember, it's plus or minus 4. Haha. So you can leave your answer like this: x equals plus 4, x equals minus 4. Or you can just be like, x equals 4 and x equals negative 4. That's fine too. You could also do x equals negative 4 and 4. Hey, but check it out. This was our solution to this problem. X squared minus 16 equals 0. But remember when we graphed it, x squared minus 16 equals 0? Same answer! So you still get the same response. And that's so good. Well, let's solve this by taking the square roots too. As well. The square roots as well. You're trying to get, that was way too fat, x squared alone. Well, you're trying to get x alone, but we need to get x squared alone first. So we undo our PEMDAS. By subtracting 6 from both sides, we get 3x squared equals negative 6. Okay, cool. We're still trying to get x by itself. So I'm going to divide by 3 on both sides. X squared equals -2. We're almost there. To undo that square, that rhymed, take the square root. So we get that x equals, uh-oh, shooties magooties, guys. We can't take the square root of a negative number. So we say there's no solution. But that's okay. Sometimes there are no solutions, and you just make do with what you have. Here we go. Last one. In solving our equation, we're trying to get x all by himself. So we get rid of everything that's gunking up his life. Just get rid of what we don't want. Clear your mind, clear your equation. We get x squared equals 0. Now we want to get rid of that square because we're clearing out the non-essentials right here. The square and the square root cancel out, so we get x equals the square root of 0 is 0. Yay! We did it. Cool, that's great and all, but when are we going to use this in real life? Well, I'll show you. Let's say that you got some shrubbery and you have enough shrubs to cover an area of 200 feet squared. What's the radius? Oh, circle. What's the radius of the largest circular region you can plant with these shrubs? So draw your best circle and then remind yourself, hey, the area is 200 feet squared. Okay, well, where do we start? Well, what are we trying to find? We're trying to find the radius. What is the radius of the largest circular region? Well, when we have area and we have radius, we know that the area of a circle is equal to pi times the radius squared. Remember that pi is a ratio of the circle's circumference to its diameter, and it's approximated by 3.1415925, and it keeps like going on and on and on. We usually just truncate it at 3.14. My uncle's an engineer. Sometimes at his work, he just uses 3.1, and that like gives me goosebumps. That's ridiculous. Anyway, I digress. So we need to figure out what is the radius. Sure. What is the radius of the circle? Well, I don't know the radius, but I do know the area. I know the area is 200. So 200 is equal to pi times the radius squared. Okay, cool. So we're trying to get the radius. So to solve this equation, let's divide by pi, which if you're using a calculator, it might have a pi button, or you can just go with 3.14. And 200 divided by 3.14 is about 64-ish. Okay. Approximately. So 200 divided by 3.4, we get about 64. Then the pi's cancel out, giving us r squared. Again, we're trying to figure out what is r. So to undo that square, I'm going to take the square root on both sides. Square root of 64 is 8. Comes out to 8.0. Is approximately equal to our radius. Oh, tenth of a foot. We need to say what it is. So 8.0 feet. That's our big answer. So you can make a circle with 8 feet of radius. That means you have one person stand in the middle of your circle, holding on to a rope that is 8 feet long, and then you have another person holding like a marker and the other end of the rope, and then they walk all the way around this whole thing, and that'll make a circle. So there you go. That's the basics. Okay, so you can solve the graphing by finding the x-intercepts. You can solve by taking the square root, which will undo the square root, cancels out with the square. And then have a great time on your homework.